Let's see how POSS can aid in processing thermoplastics. As discussed in previous infomercials, POSS has an inorganic cage at its core and organic groups attached to the corners of the cage. This hybrid organic-inorganic structure leads to POSS's unique hybrid properties. Like inorganic silicas, the POSS cage core is stable to well over 500 degrees Celsius. The organic groups will remain bound to the cage to over 350 degrees Celsius, keeping them in the formulation under almost any processing conditions. In addition, if the compatibility of the R groups is well matched to the polymer, the POSS will completely dissolve into the polymer and cannot leach out, like plasticizers and other flow modifiers. POSS is not a nanoparticle. It is better classified as a nanostructured molecule, and as such has a definite melting point. As you can see in this time-lapse video, when octamethacryl POSS crystals are heated gently with a heat gun, they melt completely. Once the heat gun is turned off, the POSS will recrystallize. You can see the crystal front descending from the top part of the beaker. High temperature stability, melting, and ease of dispersion allows POSS to be used as a flow aid for hard-to-process polymers. Polyphenylene oxide, or PPO, is very difficult to process, and therefore typically requires blending with other resins such as polystyrene. The melt flow index of PPO can be increased by up to 350% by the addition of only 5 weight% of POSS. Even polyphenylene, one of the hardest thermoplastics to process, shows a melt viscosity decrease of 40% at a range of shear rates. And unlike common diluents and fillers that can degrade mechanical properties, POSS does not negatively affect the performance or appearance of your material. Adding any amount of POSS to polypropylene does not affect its transparency because the POSS molecules dissolve in the polymer and are smaller than the wavelength of light. In addition, if the refractive indices of the polymer and the POSS are similar, you can be assured a transparent product. With PPO, common silicone flow modifiers change a translucent orange material into an opaque brown. With POSS flow modifiers, the final product is now transparent and is a much paler yellow. Polyether ether ketone, or PEEK, is another hard-to-process thermoplastic. You can see here that it flows very slowly. When low viscosity molten POSS is added to a high viscosity polymer, a diluent effect is observed. This leads to easier processing. It's easy to see how much the flow is improved when the PEEK is blended with POSS flow modifiers to make a master batch. Let's see that again. And when the POSS cools and re-solidifies in the polymer, it provides nanoscale reinforcement. High molecular weight PEEK is typically blended with the POSS flow master batch at from 10 to 20 weight%. These amounts can greatly improve melt flow. Improved melt flow will help reduce extruder torque and therefore processing costs. And POSS is a nano reinforcement and will not give any appreciable decrease in mechanical properties to over 50 weight% incorporation. POSS is a nano reinforcement that can improve the flow of even the most difficult to process materials, including polyphenylene oxide, polyphenylene sulfide, fluorinated ethylene propylene, and Torlon. Contact us. Our scientists are ready to help you use POSS to improve your polymers.